When you integrate x to the power of n with respect to x, what do you get? To answer this question, let's think the other way around. So let's think about what happens if you differentiated this function. So dx to the power of n with respect to x, this is equal to, you bring this index outside, you multiply that with x to the power of, and you decrease this index by 1, so n times x to the power of n minus 1. Now, to get n over here, since we just have to take the antiderivative, and you need to get n here at first, what do? So let's try adding 1 to the operand. Let's try adding 1 to the initial function that we had. So now d of x to the power of n plus 1 with respect to x, that gives you, now n plus 1 is a complete entity on its own, so this will be n plus 1 times x to the power of n plus 1 minus 1, and this just serves our purpose, and this becomes n. So x to the power of n is there, but then you don't have a constant n plus 1 lying around here, so you need a way to treat that. And that way will be if you divided the initial function by n plus 1, so d of x to the power of n plus 1 would divide that by n plus 1, and this has to be differentiated with respect to x. This gives you n plus 1 times x to the power of n. This just comes from this function, but then you're also dividing this by this n plus 1 thing, and since these both cancel out, you have finally the function that we are looking for. So since when you differentiate this entire function, that gives you x to the power of n, you can say that the indefinite integral of x to the power of n, that is equal to x to the power of n plus 1 divided by n plus 1. Now you need to include the plus c, the constant thing here as well, since that will run all over this course when we're studying indefinite integrals. Now let's apply this. A few things to notice. First, if you had n to be equal to -1, what happens in that case? So, okay, so if you want to plug in that, so you will have x to the power of -1 plus 1 divided by -1 plus 1 if you just plugged in n plus 1 here. And this will give you a denominator of 0. That doesn't make any sense. So what that means is that since it doesn't make any sense to put in a -1 plus 1, a 0 in the denominator, you still cannot have n to be equal to -1 here. When n is equal to -1, you do the integral of 1 over x dx, and that, which gives you the natural log of x. We'll come that to in the next video. But for now, let's just consider the fact when n is not equal to -1. And n can be any real number except -1. So if you wanted to do, let's say, the integral of x to the power 10,000, let me just remove the comma, it doesn't make any sense. So 10,000, x to the power 10,000 with respect to x, this is equal to, well, x to the power of 10,000 plus 1 divided by 10,000 plus 1. This just gives you x to the power of 10,001 divided by 10,001. You can plug in other real number here. So let's think about, let's say, x to the power of, let's take square root of 2. X to the power of square root of 2. With respect to x, you integrate this. So this gives you x to the power of square root of 2 plus 1 divided by square root of 2 plus 1. You could have rationalized this, so multiply both the numerator and the denominator by square root of 2 minus 1. This will just give you square root of 2 minus 1 times x to the power of square root of 2 plus 1. And in both of these cases, and I'm so silly I just ignored it, in both of these cases you need to include a plus c, a plus constant sign here as well as here. So for all cases, except when the index is equal to -1, you can always apply this rule to find the antiderivative, to find the integral of any x to the power of n function you find. And there are just a lot of x's flowing around here, so let's do a different variable. So if you had a to the power of, let's take -5/2 with respect to a. This -5/2 is just n in this case. So you will do a to the power of -5/2 plus 1 divided by -5/2 plus 1. This gives you a to the power of -3/2 divided by -3/2. And this will, if you wanted to write this up in a better way, so this will be -2/3 times a to the power of -3/2. And again, include the plus c sign to include the constant thing. And what this means is that if you just differentiated this function, you will get that. Do it as an exercise. See you in the next videos.